Before the exercise has started, most participants should have been affected by the process of anticipatory rise in increasing breathing rate. For example, the average breathing rate for a 16 to 17-year-old is roughly 10 to 12 breaths per minute. However, Billy's and Luke's breathing rate was at 20 and 23 beats per minute. This is due to the anticipatory rise being stimulated an emotional response that the participants had. Once the participants started this steady-state exercise, all of them increased to some degree. For example, after 2 minutes of supposedly steady-state exercise, Billy's breathing rate increased to 44. This is due to a higher detection from receptors around the body. For example, the chemoreceptors detect an increase in carbon dioxide in blood, where the muscles are being forced to diffuse carbon dioxide back out into the bloodstream at a quicker rate. As a result of this, Billy's RCC is stimulated to enable breathing rate to increase via the thyroid nerve. Similarly, Rachel's breathing rate is also increased due to one of the many factors increasing breathing rate. However, Rachel's results aren't increased as much as Billy's. This is because Billy has been incorrectly forced to work in the anaerobic range of exercise, and therefore caused his breathing rate to be above the average breathing rate during steady-state exercise, 15 to 20 breaths per minute. Similarly to Rachel, Luke's breathing rate has also increased to a small degree, however still remaining inside the aerobic breathing rate range. For example, Rachel's breathing rate increases to 16, with Luke's increasing to a higher 23. Unusually, Billy's breathing rate continues to increase until reaching a peak of 64 breaths per minute. This astonishing rate of breathing rate shows another sign of Billy being forced to work anaerobically. This would be where, due to such a strong level of intensity, the body needs oxygen to provide them fuel to produce powerful enough contractions for exercise. However, breathing rate is still elevated as a means of trying to consume as much oxygen as possible in order to prevent change of the chance of fatigue. Whereas Rachel and Luke's breathing rate then plateaus for the remainder of the exercise, which would be expected of aerobic steady-state exercise. This is where the current rate of oxygen and carbon dioxide is high enough for the working muscles to be supplied with enough means for fuel for energy. As a result of this, the body no longer has to cause an increase in breathing rate during steady-state exercise. This plateau from Rachel and Luke then is sustained for the rest of the exercise, and therefore acts as a justification for the method of their exercise being carried out correctly in terms of breathing rate. Whereas perhaps because it was realised during the exercise that Billy was taking part in, that the intensity was too high for aerobic breathing rate. Billy's breathing rate then gradually decreases until the end of exercise from 64 to 46. Finally, as the exercise is ended, Luke's breathing rate quickly decreases from 27 to 16 within 2 minutes. This indicates that Luke had little oxygen debt to recover and remove where the body has been sufficiently supplied with enough oxygen throughout the exercise. As a result of this, Luke's breathing rate doesn't need to stay elevated and therefore decreases, whereas Billy and Rachel's breathing rate stays elevated at the same result of 19 and 24 after 2 minutes of having finished the exercise. This could be an indication that there is another reason to why the exercise wasn't consistently carried out correctly, as if the participants were working aerobically as steady-state exercise. Then their body would be provided with enough oxygen to avoid a build-up of oxygen debt once exercise has ended. During steady-state exercise, the primary energy system will be used in the aerobic energy system. This is because the low level intensity of the steady-state exercise allows the athlete to breathe in efficient amounts of oxygen to act as fuel for the working muscles. Before the steady-state exercise has begun, Billy started with a blood lactate level of 1.6, which is just slightly above the average resting value for blood lactate according to Wikipedia, with the average being 0.8 to 1.5 milliliters. Furthermore, Billy's blood lactate levels are at this low level due to the body not producing lactic acid via the anaerobic system. Whilst the body is at rest, the aerobic energy system, or the anaerobic energy system, needs to be However, once the steady-state exercise has started, Billy's blood lactate levels had gradually increased to a level of 22.1, which is well into above average aerobic blood lactate levels of 1.5 to 2. Due to this being extremely high, it is clear that Billy was forced to work anaerobically during a supposed steady-state exercise, where blood lactate levels should be at an extremely low level. Normality which has occurred during the data does not match up with our hypothesis stating that the aerobic system would be the primary energy system used. This could be due to the method of the test being carried out incorrectly and therefore forcing blood lactate to be produced via anaerobic energy system use. Whereas, although Rachel and Luke's blood lactate levels are still above the aerobic energy range of 5 and 8 results, these low level of blood lactate indicate a more frequent use of the aerobic energy system, where lactic acid is prevented from being produced, as it isn't a byproduct. This therefore partially matches up with a hypothesis of relatively low blood lactate levels being recorded. Furthermore, the data presented by Billy, Rachel and Luke presents another abnormality in the fact that each one of their results still present abnormalities. For example, Billy's blood lactate levels do increase between the 15 and 16 minute mark. However, it only decreases by 5 blood lactate values, which still shows a clear signs of the anaerobic system being used, and therefore the method being carried out incorrectly. Additionally, Rachel and Luke's blood lactate levels increased to an even higher extent to present another sign that the method of the exercise has been carried out effectively. These abnormalities are once again presented during the recovery stages of the exercise, when none of the participant blood lactate levels show signs of decreasing, which could be due to because of a non-efficient result recording, henceforth leading to an abnormality of results in blood lactate. Finally, for my hypothesis conclusion, my hypothesis for the heart rate of the participant throughout steady state exercise was that there would be a slight increase in heart rate before the exercise due to anticipatory rise. After completing the test, I still agree with this statement, as all Billy, Rachel and Luke's heart rate had increased before the exercise had begun compared to each one of their resting heart rates. Additionally, I also agree with the fact that we predict the heart rate to increase or to eventually plateauing. This is due to everyone's heart rate increasing once starting the exercise, with Luke and Rachel's heart rate eventually plateauing. Whereas I've chosen to ignore Billy's heart rate as being as a correct piece of evidence regarding the abnormality which occurred. With breathing rate, my hypothesis for the participants' breathing rate was for an increase in breathing rate once they had started the aerobic exercise due to a larger demand for oxygen. I agree with this aspect of my hypothesis, as this occurred in all the results regarding breathing rate. Furthermore, I also agree with our prediction of breathing rate, which reaching a plateau, as although Billy's didn't, this was most likely due to an incorrectly carrying out the exercise, whereas this occurred in both Rachel and Luke's results. And finally, the energy systems, although none of the participants were primarily using the aerobic energy system throughout the whole steady state exercise, I still agree with our hypothesis, as the aerobic exercise for steady state shouldn't cause a high level of production of blood lactate levels. Therefore, I agree with my hypothesis.